Okay, so you've just learnt about the reactions of halide ions, specifically the reactions of halide ions as reducing agents, because we know that halide ions can reduce sulfur in concentrated sulfuric acid. What we're going to do now is we're going to look at the test for halide ions. So if you've got a sample, you want to know whether there's halide ions in there, and you want to know what those halide ions are. Okay, so let's just remind ourselves on what are halide ions first of all. So halide ions are either fluoride, chloride, bromide, or iodide. Okay, now the halide ion tests are based on the fact that silver chloride, silver bromide, and silver iodide are certain coloured solids. Okay, so you need to learn the chemical formula of these substances that I'm going to write down now and their colours as well. Okay, so you know that the chemical symbol of silver on the periodic table is Ag, and silver forms positive ions, so 1 plus ions. Chloride ions are minus, so therefore the chemical formula of silver chloride is AgCl. Now, silver chloride is an insoluble substance, so I'm going to put the state symbol solid there. It's insoluble, so it will be a solid if you were to add that to water, and that would be white. That's a white solid, silver chloride. Silver bromide, moving down the group, is again insoluble, and that is a cream colour. You need to learn the chemical formulas of these and their colours, please. Silver iodide is yellow. Okay. Now I'm going to come back to silver fluoride. So write AgF there. Notice I'm not going to write solid. I'm going to write AQ. And that's because silver fluoride is soluble in water. So it's soluble. Therefore, it will be a colourless solution. Okie doke. So you need to learn these first before we learn how to test for these. And that will become clear in a couple of minutes. Okay? So how we test for these? Well, here's an example. What we do is, the basis of this test is that we take silver ions in solution. I'll tell you what compound they come from in a second, and react that with a halide. In this particular case, let's pick chloride. So a sample contains chloride ions, for example, sodium chloride, potassium chloride, ammonium chloride. And those ions react together and they make silver chloride. And that is a solid. And we know here that it's white. Let's imagine this then. So we've got a beaker of Ag plus ions in here, and a beaker of chloride ions. And this is a solution, and this is a solution. And we add them together. What we get, because silver chloride is insoluble and it's white, you would get a solution, and in that you get these big lumps, and those lumps would be the silver chloride solid. And we'll call that a precipitate. A precipitate is just a solid in a solution. That's what a precipitate is. And that would be white. Okay? If I repeat the experiment, this time I used silver ions with bromide ions, then the product would be silver bromide solid. And then we know that silver bromide is cream, so we see a cream precipitate. or I could use the same experiment here and I've got iodide instead. That will be a yellow precipitate. Okay, let's go back to this AgF one. Now we know that one's soluble. Okay, so if I wanted to test for fluoride ions, this method would not work. So you cannot test for fluoride ions using this method. Because if I take, let's say, a colourless solution of a solution which contains silver ions in there, and react that with a colourless solution of fluoride ions, because my product is soluble, we know this because it says AQ, then that would make a colourless solution as well. So basically taking two colourless solutions, add them together, make another colourless solution. Well, you're not going to see anything happen. So you can't use this as a test for fluoride ions. You can only use this as a test for chloride, bromide, and iodide ions. So if you add silver ions to chloride ions, you get a white precipitate. If you add bromide to silver ions, you get a cream precipitate. And if you've got iodide ions, you add some silver ions to it, you get a yellow precipitate. Okay? Right, okay, clearly guys, we don't have bottles of silver ions. The silver comes in the form of a silver nitrate. So let's look at a real equation here. So let's imagine I've got a beaker of something and I'm going to tell you what's in it, but let's imagine that someone wants to do a chemical test on it and they want to work out what's actually in there. So I'm going to tell you that this is going to be salty water, all right? So it's going to be, in this beaker, NaClAq. And I want to prove that there's chloride ions in there. Obviously, we could do a flame test, couldn't we, to see if there were sodium ions in there. You might remember that from GCSE. We're not looking at that today. We're just looking to test for halide ions. So I want to prove that there's chloride ions in my salty water, in my sodium chloride. So what we can do is we can add to that silver nitrate solution. So silver nitrate solution, the chemical formula is AgNO3. It's AgNO3 because Ag is plus and NO3 is minus. So that's the chemical formula. So add that to that, and if there's chloride ions present, then we know we get a yellow precipitate. And we will be, sorry, a white precipitate, because chloride's white. Yellow would be iodide. A white precipitate, if that's what's in there. All right. So let's have a look to see what's happening here. So the silver nitrate will react with the sodium chloride, and that will produce silver chloride. That's very important that you get the state symbols correct. So you have already learned that silver chloride is insoluble. Therefore, it must be a solid which is produced, and that is your white precipitate. So you have a solution and a solution. They react together to make silver chloride and the white precipitate. Let's have a look at the ions which are left. So I've got the nitrate ion and the sodium ion. So it's going to make sodium nitrate. And that will be a solution. That will be the overall equation for this reaction. And that will be a test for chloride ions in sodium chloride. Let's now try and convert this to an ionic equation. And hopefully we can get back to that point there. So what we've got here, then let's draw this out. Let's draw this solution here. I have a beaker here of silver nitrate. So I have water in there because it's a solution. I have silver ions floating around, and we'll have nitrate ions floating around in our solution. I'm going to react that with some sodium chloride solution, H2O because it's a solution, sodium ions floating around, and chloride ions floating around. React them together and we'll make this precipitate in this solution. Let's just draw this a little bit bigger then. So we've got water in here still. And we've got these lumps of precipitate, which means that the silver ions are chemically bonded to the chloride ions. They're not separate, they're a solid there. It'll be a giant ionic solid. So I'm going to draw my lump of solid there. I can draw a big square there to represent my lump of solid, my precipitate which has been produced. AgCl solid. And that would be white. That'd be a white precipitate. So it's big lumps of white precipitate in here. Let's draw our sodium nitrate solution, which is produced as well, and that will be around the white precipitate here. So this is sodium nitrate solution. So it contains sodium ions, which are in solution, and nitrate ions, which are in solution. Let's have a look to see what has changed and what hasn't. So we've got water before and after. So the water is not involved in the chemical reaction. The water is just the solvent there. The silver has gone from silver positive in solution to silver solid, so silver chloride and silver chloride solid, so that there's a change there, and the chloride has changed as well. But if you look at the nitrate ions, you've got nitrate ions that are floating around in solution here, and also just nitrate ions floating around in solution there. So nitrate ions are spectate ions. So these are spectate ions. And the sodium ions are spectate ions as well. Because the nitrate ions and the sodium ions are spectate ions, we don't include them in the ionic equation. So the ionic equation is only the ions which change. So the ionic equation in this case is Ag plus AQ plus Cl minus AQ makes silver chloride solid. So that is your ionic equation. It doesn't matter whether it was sodium ions or potassium ions or lithium ions, it's the same ionic equation here. Obviously you read a different balanced symbol equation, but the ionic equation will be exactly the same. And this ionic equation matches this one here. Okay, let's have a go at testing for bromide ions, but let's pick something completely different. So let's say I've got a sample this time, and in there I think there is lithium bromide, but I want to test to see if there's bromide ions in there. So what you would do is you would put in some silver nitrate solution to your lithium bromide solution, and then there'll be a chemical reaction. So we have a silver nitrate solution which would react with lithium bromide, and that would make silver bromide solid, which is cream. So you need to learn that colour. So make a cream precipitate and lithium nitrate solution. So the ionic equation in this case would be silver ions from the silver nitrate solution reacting with bromide ions from our sample to make silver bromide, which would be my cream precipitate. You can see a cream colour there produced. Alright, or if we have another sample here, and in there we've got potassium iodide. Same method, put in some silver nitrate solution. So I'm going to write down the balanced symbol equation and the ionic equation, just like I've done in these two examples here. So our balanced symbol equation is silver nitrate plus potassium iodide solution makes silver iodide solid, which is a yellow precipitate. And potassium nitrate solution. The ionic equation in this case would be silver ions plus iodide ions that are in solution makes silver iodide solid, which is our yellow precipitate. Remember, this doesn't work for fluoride ions because silver fluoride is insoluble, unlike silver iodide, silver bromide, silver chloride. Okay, so remember the colours: white, cream, yellow. All right. Okay. Now, a problem is, with this experiment, is that any impurities can actually spoil the chemical test. All right. So, if I had an impurity in there, an impurity is something which is in there, which is going to interfere with our chemical test, which is going to give what we call like a false positive. So we're going to think there's something like chloride ions in there, but actually it isn't chloride ions. It's just the silver ions are reacting with something else, which also produces a white precipitate. All right. So if we had carbonate ions in there, so if our carbonate ions was our impurity, so imagine this is an impurity in there, carbonate ions. Unfortunately, the silver ions would actually react with the carbonate ions. Now, let's balance this one. A bit more tricky, this one, because you've got a positive charge here and a 2- charge there, so you actually need two of those. It actually produces this substance called silver carbonate. Now, the problem with silver carbonate is that it's insoluble as well, and it's white. It's white and it's insoluble. So, therefore, you get a white precipitate. So when you do the experiment and you go, oh, I've got a white precipitate, that doesn't necessarily mean you've got chloride ions, because silver carbonate is a white precipitate and silver chloride is also a white precipitate. So that's one problem, okay? And what we can do is we can get rid of this impurity. But let's have a look at another impurity. So another impurity is when the silver ions react with an impurity of hydroxide ions. That would make silver hydroxide, which again is a solid, so you'd see that as an impurity. So what we need to do is we need to add something to react away these impurities. So we need to add something to react away these impurities before we do the chemical test. That something needs to be able to react away these, but not react away our halide ions, so chloride, iodide, and bromide. And that's something that we use is nitric acid. So we add dilute nitric acid to get rid of any carbonates or hydroxide impurities. We do that first. So we add dilute nitric acid, HNO3 aqueous, to react away any impurities that might interfere with a chemical test. So that's what we need to do first. That's our step one. So step one is to add dilute nitric acid to react away any impurities. Step two is to add the silver nitrate. So if you're asked in an exam what method you would use, let's say, to test for bromide ions, then what you would say is, the first thing you would say, you get points for, you would say, I will add some dilute nitric acid to react away any carbonate and hydroxide impurities which might interfere with a chemical test and produce a false positive, because they will produce a precipitate. Once these are reacted away, I would add some silver nitrate solution, and if the precipitate was cream, then I know that I've made silver bromide. Therefore, I must have had bromide ions in my original sample. Okay, so that's what you would say if you were writing the method. Okay. Now, our problem is this, right? Let's imagine we've done like a series of experiments. Done a series of experiments, and we've got 3 test tubes here. And in this test tube, we can see what we think is a white precipitate, and what we think is a cream precipitate, and what we think is a yellow precipitate. And if we are correct, we know that the white precipitate is chloride ions, the cream precipitate is bromide ions, and the yellow precipitate is iodide ions. But the problem is, you'd be the same as me, you'd be looking thinking, is that cream or is it white? Is that yellow or is it just a light cream? Is this a very, very light yellow or is it cream? So it's sometimes quite difficult to tell whether something's cream or white or cream or yellow. So what we need to do is we need to do like a second test after we've done this test. So if we've got a cream precipitate in here, we know that we've got some silver chloride in there, a white precipitate rather, and cream precipitate we'd have some silver bromide in there, and yellow precipitate we would have some silver iodide in there. What we can do is we can add something else to all of these test tubes after we've done the test, just to check that this one's chloride, this one's bromide, and this one's iodide. Okay? Now, what's clever about this one is, if you wanted just to double check that this one here has got chloride in there, what we do is we take our product from the first test, which is our white precipitate of silver chloride, and then we add dilute ammonia. So we add dilute ammonia. So ammonia, remember, is NH3. And if we add dilute ammonia to the silver chloride solution, then what happens is the white precipitate redissolves. In other words, it disappears. Okay? We don't say it disappears though, because it's still in there. It's just, it's not precipitate anymore. So the white precipitate redissolves. And then we know that we must have had silver chloride in there. And that just confirms that it was actually silver chloride. Okay? And that is because silver chloride is very soluble. Very soluble. Compared to silver bromide and silver iodide, okay? It's still not soluble in water, just water, but it's very soluble in ammonia, yeah? Compared to silver bromide and silver iodide, all right? Now, if we were to do the same test, the same thing, and put that in the cream precipitate here, in the silver bromide, the AgBr, which we think is cream, and we added dilute ammonia, so there'd be no change, yeah? You'd still have a cream precipitate. There'd be no change. Alright, there'd be no change. And that's because silver bromide is less soluble than AgCl. So AgBr is less soluble than AgCl. If you want to confirm it was the cream precipitate, what you would have to do is, you wouldn't use dilute ammonia, you would have to use concentrated ammonia. So you take your AgBr solid, your cream precipitate, and you'd add concentrated ammonia. If you added concentrated ammonia, it would dissolve. So you need a higher concentration, so it would dissolve. If you want to be sure that these are iodide ions there, what you would do is you would take your silver iodide precipitate, which would be the yellow precipitate, and then you would add concentrated ammonia, and if it still didn't dissolve, you know that it's silver iodide and not silver bromide or silver chloride. Yeah? And that's because silver iodide is even more insoluble. Even more insoluble than AgBr even. Okay? So this just kind of confirm this if you've got these 3 test tubes. Imagine you've got 3 test tubes here, right? You've done the experiment, and let's imagine you don't know the difference between white and cream or cream and yellow, right? What you'd do is, I would do this. I would stick dilute ammonia in all of them. Put some dilute ammonia in there, dilute ammonia in that one, dilute ammonia in that one. Okay? Now, only one of these it would redissolve, and that is this one. So if I put dilute ammonia in all of them, this one will redissolve. Therefore, I know that this one must be chloride, this reaction here. So I know this one's chloride, so I'll take that one off, I know that one. Right? Then what I would do is, I would put concentrated ammonia in both of those. And what I would find is, I'd find that this one here would redissolve. Because if it contains silver bromide, that's soluble in concentrated ammonia, but not dilute ammonia. So I'd know this one. The one which is left over would be the yellow precipitate, hopefully, and that would be the one which, when you add concentrated ammonia, there'll be no reaction. So therefore, the one left over would be that one. And that's how you would tell the difference. So there's a few steps there, isn't there, for testing for halide ions. Your first step is to add dilute nitric acid to react away any impurities. And those impurities are carbonates and hydroxide, because silver carbonate and silver hydroxide are white precipitates. Then what you would do is, you would add, second step, you would add silver nitrate solution, and if it was chloride, it would make silver chloride, which is a white precipitate. If it was bromide, it would make silver bromide, which is a cream precipitate. If it was iodide, it would make silver iodide, which is a yellow precipitate. And just to make sure, I would put dilute ammonia in all of them. The one which redissolves would be chloride. I would then put concentrated ammonia in those two, and the one which redissolves would be bromide, and the leftover one would be iodide. Okay? Now, I did say that at the very start, step 1, the acid that we have to use to react away any impurities was nitric acid. Okay? So, you can use nitric acid. You cannot use hydrochloric acid, and you cannot use sulfuric acid. And you need to know why that is. This one is relatively straightforward. It's obvious, this one, isn't it? Because if you add HCl, I'm going to emphasise this Cl bit, to get rid of any impurities, what you're doing is you're actually putting chloride ions in there, because HCl contains chloride ions. So those chloride ions would actually end up reacting with silver ions, and that would make a white precipitate. So you'd think you've got chloride ions in your sample, but you haven't. It's just because you used the wrong acid to react away any impurities, and what you've actually done is you've actually put impurities in there. You put chloride ions in there. So you need to be able to explain in your notes why you can't use chloride ions. So you need to explain that. You can't use sulfate ions either, yeah? And the reason why you can't use sulfate ions is because if you put sulfate ions in there, which are SO4 2-, then they will react with silver ions. Guess what they make? Yep, they make a white precipitate. They make a white precipitate, and you think, oh, brilliant, I've got white precipitate. There must be chloride ions in there. But actually, no, you just put sulfate ions in there, and the sulfate ions have reacted with the silver instead to produce silver sulfate, and that is a white precipitate. Okay? So you need to explain why you can't use sulfuric acid. Okay? Nitric acid, remember, the nitrate ions, the nitrate ions can react with the silver ions, but silver nitrate is soluble. Okay, so it's not going to produce a precipitate at all. All right. So that's how you test for chloride, bromide, and iodide. Remember, you can't do fluoride. You can't do fluoride because silver fluoride is soluble. Yeah, so you can't use this test to test for fluoride ions. So it's important, I think, we kept that separate to the rest of 10.3 because what we're doing here is we're testing for the ions rather than reacting them. So I thought it was important to keep that separate. Okay, thanks very much.